Okay, good evening. I assume you all can hear my voice and see my screen. So far, only 32 participants. I think I was delayed to invite you, send you the link via the mail, because few seconds before 6 p.m. a few minutes ago, I came to my quarters. So I was busy with some other work, with meetings and other stuff in the office. So that's why the delay. Sorry for the delay, and we will start the session. If you can uh, clearly hear me and clearly see my screen, that's why I need your uh, response, for your feedback.
Yes, sir. Can hear and can.
Okay. So last day we have been developing this small program. So we have introduced a rule uh, which logically explains the relationship between the uh, child and a mother. Child and a mother. Or in other words, the conditions need to satisfy to become a mother. So you know, you already aware that this what we call the comma. Comma denotes in Prolog the AND operation, logical AND operation. So what the two conditions need to be satisfied by a person who is willing to be a mother, who is going to claim as a mother XY. So X gonna be according to my personal preference, that means my style. So X is the person going to be the mother. Somebody else can define this in the other way. That means Y is the mother. So this my convention, my own preference is the first parameter, the first variable refers to the what we would the function. So X is the mother. So X gonna be the mother of Y. X is the mother of Y according to my style of defining these knowledge, or what we call the facts. And this is the condition. This is the condition or the eligibility requirement or the qualification that X need to satisfy in order to become a mother of Y. So X need to be a parent. X needs to be a parent. Of course, mother is a parent, father is another parent. X needs to be a parent of same Y. Y is the child in this case, in this scenario. So X needs to be a parent of the same child Y. Remember, same Y here. Okay. Besides the two, this clause that what we call the, to denote the if else, something like if else condition, we use this combination, the what we call the colon and the dash in Prolog. So this is a comment. This is not a instruction, or this is not a thing written in the Prolog language. So this is just to clarify, just to explain what's going on. This is comment. It will be ignored, skipped by the compiler at the compiler time. That will be not taken to the consideration. This whatever starts with this percentage mark, similar to this this thing in most languages. So two conditions, X needs to be a parent of Y, of course. Meanwhile, X needs to be a female person. X needs to be a female person. So female something is defined previously. We have already defined, we have listed all the female candidates or female persons. So that means a mother is defined in such that a female parent. So that is the literal meaning of this particular sentence or the clause. We call it's a clause or state, prolog clause. Okay. So this means, so if we analyze or if we interpret in a programming manner, so this is the meaning. If capital X is the parent of Y and X is a female person, then X is the mother of Y. That is the programming meaning. If we combine these, if we use this if else and then like our terms, those are recognized by the compiler and familiar to us for the programmers who are programming in other languages like Java, C++. But if we consider the general plain English meaning, it's nothing but it's very simple. A mother is a person who is a female parent. A mother is a person who is a female parent. So that is the meaning in English. And if we further analyze it in from a programming perspective, from if we interpret this from a programming point of view or in the context of programming, so this is gonna be the what we call the so the meaning or what we call the yes, meaning is the appropriate term. So we are going to expand the same program from this point onwards. We are going to add more relationships. Now we have 38 participants. Good. So it's very hard to move this. You call this bar or something. Okay. Now we are going to add more. So this is not a rule. This is just a fact. Check whether we are already having that. Yeah, husband, that is also already available. Now mother has been defined. Now I am going to define the relationship son. Okay. Second rule. So this is let's say rule number 1. So this is gonna be the rule number 2. Rule number 2. Okay. Son. Son is a child. Son is a child who is a male person. That means in plain English, a son is nothing but a male child. A son is a male child. Let's examine the anatomy, that means the composition more deeply. Son X, that means X is the person going to be the son. X is the person who is claiming that he is a son. X is the son of Y, that means Y is the parent. Y can be either mother or father. So X gonna be the son of the family. Okay. So X might have 2 parents. X might have mother. It should have mother and a father as well. So the same X, who is the son, is going to be a child for a while. And that child has a parent, the same parent, Y, which is in the left hand side of the clause. So the two sides are defined leftward to this one and rightward towards right hand side to this one. Okay, so this is the breaking point, or what we call the margin or the boundary of the two sides that we traditionally talk about. Okay, consider it's kind of a convention. It's not a hard and fast rule, so it's kind of a convention or common agreement we come to in order to make it more easier to understand and analyze. So sun x is the sun of y one at that different instant. Same x will be a child of same y. But there's another condition that the person who claims as a son need to satisfy, that is x must be a male person. In other words, simply a son is a male child. Son is a male child. So we have already defined the child. If it is not there, we have to define the child relationship here. It seems the child relationship has not been defined here. So we can copy it from the previous parent. Child that is not defined here. So mother, parent. So I will define it. Who is a child? Okay. Since this is a fact, it's better to begin another rule. So who is a child? So child x, y. Okay. Child is the opposite of parent, inverse of the parent. We have already defined the thing called parent. Parent y x dot. We have to demark, we have to put this punctuation or what we call the full stop. Otherwise, the compiler doesn't know, can't find where's the end of the clause or the rule. So now this gonna be the rule number 1, the traditional or well-known rule, and this gonna be the rule number 2. This gonna be the rule number 3. Now, since we wanted to implement this son relationship that will consist of this child relationship, which has not been introduced or declared on a previous stage. Therefore, we need to well define this child relationship. Who is a child? Child x, the child x, the parent y is where the inverse relationship of xy. That means where x becomes a child and y becomes a parent. Here y becomes a parent and x becomes the child. So I think now you have an idea. Now we have defined 3 rules. Now we have 3 rules. So we will try to execute this, try to run this beforehand, moving into more, adding more complex relationships. So now I am going to run this. First of all, I need to compile this. True with warnings. True with warnings. True means compiles. Probably for Windows users, you might not need this additional step, this compiling, or what we call the specifying the path name, file path name, and other additional work may not require. And now, first of all, I will test my clauses. Child xy dot Kasun Rani. Is that correct? Yeah, Rani Kasun. Kasun is the child and Rani is the parent. See, we have stored the knowledge. We have represented the knowledge using a fact, using the parent relationship. Now we are asking about we are querying about the child relationship, which is the opposite of that. It is the inverse of the. So it might have more matching pairs of value sets. So we can continue with the semicolon. Shanuka and Kasun. Shanuka and Kasun. Kasun Shanuka, this one, okay? And Shanuka and Shehani. Okay, Shehani. Sanuki and Kasun. Sanuki and Kasun. This one. Okay. More pending results. Sanuki and Shehani. Sanuki and Shehani. Okay. Vimal and Gunapala. Vimal should be the child. Yeah, Gunapala is the parent of Vimal. Finally, Vimal and Gunavati. Gunavati is the mother of. Shall we check the mother relationship? Then mother X. I want to check who the mother of Vimal. Gunavati. Vimal got only one mother, otherwise it would be funny, no? Vimal's mother is Gunavati. So you can ask somewhat a stupid question, something like that. Does Vimal has a mother? Of course, if you couldn't specify this fact in your program, of course, sometimes you will get a funny answer, something like that. Vimal doesn't have a mother or something. So this question specifies the query says ask since I have used underscore other than instead of or other than a variable or capital letter. So this should give we can predict the output as either true or false since Vimal's mother is introduced to the program. So this should give true, only one true. So we can further test this mother. We can test mother. Who are the children of Gunavati? Let's ask the simplest question. Does Gunavati has children or does Gunavati is a mother of somebody? True. Okay. Mother Gunavati capital C, seeking for the children. Okay. Whatever the capital letter that will be interpreted. Vimal. Gunavati has only one child. His name is Vimal. Let's try with some other. Let's say Kasun, who is not a qualified person. Capital capital X something. False. False means Kasun is not a female person. So what is the condition need to satisfy in order to become a mother? She must be a parent. Meanwhile, she should be a female person. Okay. So I think you have an idea how the implementation of this mother works. And we can test the son relationship now. We can list down all the sons. First, Kasun and Rani. So X is the son. So Kasun is the what we call the son, and Rani is a parent. We don't know. Why can be either mother or father. Shanuka Kasun, Shanuka Shehani. That's all. Only male children will be listed here. Okay, so we can ask the question in a slightly different way. List down the sons. We don't bother about the parent. List down the sons. We don't need the name of the parents. Kasun, Shanuka, Shanuka. Why this Shanuka appearing twice? Because Shanuka becomes a son for a mother, for his mother, and for his father. Shanuka becomes a son of his father, whoever, and Shanuka becomes a son another time, again for his mother. So you can ask so many questions. Son, let's say Kasun, capitals P to denote the parent. That means who are the parents of Kasun? Who are the parents of Kasun? Rani. So Kasun got only one parent, Rani, according to the knowledge specified in this program. Kasun, that means the father of Kasun is not specified here. Father of Kasun is not specified here. You can ask a stupid question, son. You can mention a female name like Rani. Say Sanuki, parent of Sanuki. False, because Sanuki is not a female per child. So I think you grab the pattern. You understand the what we call the pattern. How these prolog inferencing is happening. Now you can we can keep adding more rules, introduce more complicated relationships. So this time I'm going to introduce a bit complicated rule. So this is going to be the rule number 4. Number 4. So I need to close this, otherwise because I need to recompile once I modify this. Sister. This time it got 3 conditions. The person who is willing to claim as a sister, okay, you can put S and B here, capital S and B. S and B, or sister can be a sister of another female sibling. No, therefore we cannot put B or something. Better to have XY as it is. Okay, otherwise you can put capital S or something. It's up to you. Okay. So this time the person who wish to claim as a sister need to meet 3 different conditions. Three different conditions. What are those three different conditions? One time, they should. So X is the parent of, X is the sister of Y. That means X is the sister of Y. So Y can be either a male sibling or a female sibling. That means Y can be a male person or female person. Anyhow, what is the relationship between the X and Y? They have common parents. They have common parents. You can, instead of parent, you can put mother. So if you have declared father, you can put father. Maybe if they are half brothers or half sisters, that means they have only a single shared parent, same mother or same father, not both. So it's not common in Sri Lankan context, our culture. So if you go to European countries and other so-called developed countries, these half brothers and sisters are very commonly found. So we forget about that, that which makes more complicated, unnecessarily complicated. So we try to understand, realize that means the meaning of these three, the prologue clause or the rule which has three conditions. Three means actually two conditions. So this is the same. That means X and Y. So X gonna be the sister, Y gonna be the other person, the brother or the sister of the person X. So X is the sister in this case. Okay. So X and Y have both have a common parent called Z. X and Y both have a common parent Z. So a third person involves. So this is somewhat a single clause, but you have to use a bit lengthy statement because this is how to write, how to tell the compiler or the program X and Y are having the same parent. That means X and Y are the children of same parent Z. So if you have mother or father, you can replace the term parent with mother. And this is one condition, X and Y should share a parent. Should share a parent, that means should have a common parent that can be the mother or father. Meanwhile, another condition need to be satisfied by the X, not the Y. Y can be either a male person or female person. So X, the person who claims as a sister, should definitely be a female person, otherwise she is not a sister. So we can write the same rule using a different way. So an alternative way using the child relationship. Okay, so we have declared the child relationship here in rule 1. So we can use the child relationship. So child, this time child, X and Y are going to be the children of P. P or Z or whatever, okay? As a capital letter to denote it's a variable. Okay, P means parent I have taken. You can put Z instead. So the same rule that I have declared here can be redefined or can be alternatively defined, declared using this manner. So I put this for ALT. So alternative form. Sister XY is the, that means the X and Y who are the siblings or the brothers and sisters, they have a common parent called P. They both are children. X and Y are children. In this, if we go to the original statement, forget about this one. Okay. This editor is annoying. So sister, they have a common parent called Z. Okay, I will introduce more rules before compiling. Now I am going to introduce the rule wife. So we have a fact, it's not a rule. We have a fact that Qasun is the husband of Shehani. Qasun is the husband of Shehan. That means Shehani and Qasun are couple. That means husband and wife. So I'm going to define the. So before going to that one, so you can define the brother relationship if you like. Okay, you can define the brother relationship by following the same manner, similar manner. So brother, same scenario. They both X and Y have same a shared or common parent. This time X, who is going to be the brother, is a male person. That's all. Okay. So rule number 5. Okay. Now we try to understand, to define the relationship wife. So wife, what is the what? This is the. So we have already defined the fact husband. Okay. So wife is the inverse of husband. We can say inverse for the ease of understanding. So here XY, here YX, like parent-child. So the somewhat inverted relationship. Okay. So wife is the inverse of husband. That means X, when X is the wife of, sorry, when X is the wife of Y, then Y is the husband of X. Okay, you can understand this, I think. So if this is confusing, we put W H, then wife, husband. Now husband, wife. Okay, clear? Wife is wife of the person H, husband. Is if so, this means if so, then H is the husband of W, and this H, okay, husband should be a male person, and of course wife should be a female person. We are double checking. Okay, actually we don't need this thing. This is unnecessary, checking the gender of the husband. This is something very bad. This is something additional. Okay, even this is enough. Okay, Even this is enough. Checking the gender of the wife, that is more than enough. But just to increase the accuracy, or what we call the enhance uh, the reasoning efficiency, or what we call the accuracy of the output, we are double checking that whether the person H is a male person. That is for the uh, security. Okay, that is something we can strengthen the inferencing, the accuracy of the inferencing. So even this is enough. Okay. So by following the same manner, so you can so husband relationship already there. So so if we have what we call the such scenarios, so you can the program can detect, recognize. And I think now we try to compile this. Okay, true, no errors. Warnings are there. We will first check the, we have already tested the mother. Now we test this sister. We put sister XY. Sanuki and Shanuka are brothers and sisters. Sanuki and Shanuka. Sanuki, okay. Sanuki is a child of, Sanuki is the daughter of Kaso. Sanuki. And Sanuki is the daughter of Shehani. And Shehani has another child called Shanuka, who is going to be the brother of Sanuki, because they both have a common parent. That means their mother is the same person, Shehani. Okay, and their father, another parent, the other parent, Kasun, is also the same. Sanuki and Shanuka, they have the same father. So as I told you earlier at the very beginning of these practical for intelligent systems, so you can take your own example. That means you can replace these names, these Kasun, Chehani, Vimal, Rani, Shanuka, these things with real names, that those are familiar to you. That means your family. That means you can replace your name, your sister's name, your brother's name, your father's name, your mother's name, your grandfather's name, your auntie's name. That means your brother-in-law's name, your sister-in-law's name, their children's name. So on. So you make your own version. So don't try to create a clone of my program. Okay. So you make your own version. Then you that means the confusions will be minimized. That means the opportunities or chances to get confused of defining rules, of interpreting rules, of defining these multi-conditional things will be easy for you. That means just rather than just copying, because I'm not familiar with these Tamil names. There can be some Tamil speaking students. So they can substitute, they can replace your own family names. Then the understandability will be enhanced. So this is just an example. Let you get familiar and get you an idea how this particular thing called Prolog, programming in logic, or especially more specifically SWY Prolog, behaves. It's up to you to create your own version and try to understand or try to make it your own. So since it is blinking after a white space, this might have more candidate value sets, pairs. So x equals y equals Sanuki. What's that? X equals y equals Sanuki. So Sanuki becomes the sister of herself. How funny. X equals y. According to the conditions we have specified, the program used to think that, so why Sanuki herself cannot be a sister to herself? Something like that. Okay, so because this is, I have already mentioned that. So this is a list processing language. This is kind of a very early AI programming language, which is relying upon the technique called LISP, list processing. So this is based on the recursion. Recursion means calling the function declared within itself for something. Okay, you know the recursion with some other programming languages. Because of the recursion, avoiding looping and other things, the big O notation, that means the complexity has been reduced drastically. So I'm not going to explain the backend. So we were supposed to explain the write the backend, the code, the source code of the backend of this program for our postgraduate. So what you are doing, just touching at the surface level. So if you cannot understand, please improve your analytical skills and your thinking abilities. I can't help you. This is very, very simple. That means just practicing these things with examples rather than understanding what's going on at the back end. So I'm not asking you to understand the back end, the what we call the mechanism or the routing. Okay. So this is very simple, extremely simple. Just follow me. Okay. So so if we want to avoid these kind of unnecessary inferences, unnecessary conclusions made by Prolog, so we can improve, we can add more conditions. So for an example, for this inferencing, for this inference, x equals y. That means x is a sister, no? So the program is used to think that, so why not x cannot be the same person of y. That means Sanuki is a sister to herself. So that is how AI works. So there can be more fascinating answers. We'll continue. Sanuki and Shanuka. Okay, Sanuki and Shanuka, it's appearing again. It's appearing again. Maybe because of two matching scenarios. So one from sister relationship and the other from brother relationship, maybe. Okay. Again, at the same is there false. So we can do something probably from this brother relationship, this the second inference, the second attempt, the reappearing of this happened. So we can test the same thing again. I ask, who is the sister of Shanuka? Who is the sister of Shanuka? Capital S, okay? Capital S means a variable. Sanuki, two matching scenarios gives the same answer. Sanuki is the sister of Shanuka. Now I am going to test the wife rule or the inferencing. So this time I'm going to ask, who is the wife of, let's say, Sanuki, sorry, it's not, should be a male person, who is the wife of, let's say, Kasun. False, because the Kasun's wife has not been defined. Kasun's wife has not been defined. How that happens? They have children. Apparently, it is Shehani. Apparently, the Kasun's wife is Shehani. So, if so, yeah, Kasun has a child called Shanuka, and yes, Shehani also has a child called Shanuka, and these two must be husband and wife. So why the system could not figure that? Because we have defined the husband-wife relationship in the way that wife is the inverse of husband. That means if we have defined the what we call the husband knowledge as a fact, then only it is it will be giving the answer, but still wife Kasun, it should give you the answer. We'll figure out what's going on. Female W, probably the female. This is a reason I think the condition we go to the condition W must be a female person. Then who is the wife of Kasun? Who is the wife of Kasun? That means who are having the shared children? Shehani. So we have not defined that Shehani is a female person. That's the reason. So we will add the rule here. Female who is the person who was missing? Shehani, female Shehani. Got the point? So according to the, in order to answer this query, so this checks the gender of the husband, as well as the gender of the wife. So if we don't provide the information that the particular person who is going to claim or who is going to qualify, if we don't specify the gender as female, okay, the program cannot fetch, or program get confused. So we will try to ask the same question again. Okay. Okay. Now we'll ask the same question. Wife. Now we want to figure out who is the wife of Hasun. Now this time it gives Shihani, because what was happening there, the gender of Shehani was not specified. Then the rule often checks for the gender of the wife. Whoever the person who claims as the wife should have the identity, the unique gender identity as female. Okay. Now the problem has been solved. That's why you need to be very careful. That means you need to provide all the necessary information. Otherwise, it will be misleading. Okay. Now I think you can declare the husband relationship No need to declare, it is already there. Okay, husband relationship as a fact, it's already there. Wife relationship is there. Remember, if we couldn't mention the gender of the husband we are claiming, then also we will not get the proper answer. That is the nature of this. So that means without having proper knowledge, so the program is not liable to answer you. Remember that. If you don't provide necessary information, essential stuff, the program will fail to infer. So especially be careful when you declare the rules, conditions. What happened to us for not getting the expected answer in the previous attempt? What happened to us? Because we couldn't define the gender identity of the person Shehan. Okay. Now you can ask more questions. Why? Let's ask whether this Vimal is a married person. Okay. So there should be a comma. So what I have asked here, whether Vimal is a married person. So we can check with this relationship. So I put underscore, that means I don't need the, I don't worry about whether about the name of the wife of the Vimal. I just want to know whether Vimal got a wife or not. False. Why is that? Why is that? Vimal, of course, Vimal is a child of Gunavati and Gunapala. That's okay. And who are the children of Vimal? It's not defined here. Children of Vimal, not defined here. Okay. Therefore, you can't ask this. You have to ask the let's ask the same question for a different person. Wife of we already asked about Kasunno. Now we can ask the same question regarding Gunapala. Okay, Gunapala, wife of Gunapala. False. Gunapala is, although apparently Gunapala's parent wife is Gunavati, but her gender is it's provided. Gender is provided. Maybe the gender of Gunapala is not properly defined. Gender of Gunapala is not male Gunapala. It's also there. Female Gunavati, it's also there. This is the reason. So we are not checking whether they have common children. We are not checking whether they have common children or not. What we are checking, whether they are matching with the husband knowledge, husband relationship. So we are checking the inverse of the husband, but we are not checking whether they are having common children or not. So that means now I'm going to define this again. Wife, okay, not wife, spouse. Spouse means either wife or husband, the partner, married partner, okay. Spouse, X and Y. It's a symmetric relationship. That means when X becomes a spouse, Y also becomes the spouse of X. Spouse is the term used in English for both wife and husband. Okay. In Sinhala, that is called Kalatraya, or the married partner. Spouse means the married partner. with regardless of the gender, with regardless of the gender. Now I am going to declare the spouse relationship using a different format. Now this time I'm going to check whether they have common children, whether they have same children. Now I put parent. So spouse X have some children. X have some children. Okay. And Y also have the same child. X got some child. Y also has the same child. That means X is a parent. We don't worry regarding their his or her gender or sex. Y is also a parent, but both X and Y are having a common child, the same child called C. Okay. That means this time we are not worrying about the gender of the spouse or husband or wife. So what happened? We get false here because this was often seeking for the what? Often seeking for the gender of the two people and the inverse of the husband relationship. If we couldn't specify the husband relationship, what will happen? The program fails to reply us or respond us. This time, without having this one, I am going to define a symmetric relationship called spouse. Now I am going to define the term husband and wife using this one, spouse. So wife is a female spouse. Wife is a female spouse. You got the idea? This is a better way of writing the same condition, same rule. So I declared the thing called spouse. That can be either husband or wife. Now I say wife is a it's better. Now it is saying wife is a female spouse, female partner, married partner. So what is the condition to become a spouse? They should be parents of the same child. If they don't have children, some married couple, they don't have children. If so, you can implement this one. So there can be multiple ways of defining or identifying or recognizing a spouse, a wife, a husband, or a person. There can be multiple ways of identifying, recognizing the relationship. That is, so now we can recompile this and check for the status. Now I call the function wife. Let's say W Kasun just to check. Shehani, okay. Now it is checking. Now I have commented this one. Now the program doesn't check for the inverse of the husband. That does check for the common children. Shehani, that's all. If Kasun has got more than Shehani, that will be another problem. Therefore, it shouldn't be like that, okay? Now you can ask wife of Gunapala. Now it gives Gunavati. So it seems it's a better way of defining the wife-husband relationship using the relationship spouse, then identifying a female spouse. So how to identify the spouse? They have common children. They have common children. I think that's enough for today. Now you got an idea how these particular things work. I think you have observed the things. At least if you couldn't follow me and couldn't what we call if you couldn't what we call practice this using your own computer, so at least you could see what's going on. So I'm going to end up the session for today. How was the thing? Was it okay, and was it understandable, and was it interesting or boring? Tell me.
It is okay, sir. Okay and interesting.
Okay. Oh, okay. I'm going to wind up and good night for all of you, and thank you very much for your cooperation.